For these problems, we're interested in whether a function is even, odd, or neither, and what are their symmetries that go with being either even or odd. So we'll start with our first example of 3x to the fourth as our function. Let's see, f of x equals 3x to the fourth minus x squared. Now, in order to be either even or odd, we need to know the fact that of what happens when we evaluate the function at the opposite of x. If the function evaluated at the opposite of x equals itself, that means it's even. If it equals the opposite of itself, that means it's odd. So for this function, what it means is we'll replace every place we have an x with the opposite of x, expand the expression, and see what we're left with. Now in both cases, we're raising the opposite of x to an even power, in this case the fourth power, so 4 negatives would make for a positive, and that will yield x to the fourth. Minus, same thing with the square, 2 negatives would yield a positive, and we'd have x squared. So you can see as a result that we end up with the same thing as the original problem. And therefore, this problem is an even function and has symmetry with respect to the y-axis. Now we're going to do the same thing for a different function. This time our function will be x to the third plus 2x. And we'll take the same approach. We're going to replace the x with the opposite of x everywhere the x occurs. So we have x to the third, so we'll do the opposite of x to the third plus 2 times the opposite of x. And we'll do the same thing. We'll simplify. So in the first group, when we take the opposite of x to the third power, 3 negatives would leave us with a negative, and then x to the third. And then the second grouping, we have a positive 2 times a negative x, and that'll get us a negative 2x. Now we can see that the signs of each of the terms switch from positive in the original function to negative. So we could take out that negative, and that would leave us with x cubed plus 2x, which happens to be the original function. So what we get on this one is the opposite of the original function. And when this happens, that means the function is odd, and therefore we'll have symmetry with respect to the origin. That means for every x, let's say, we'll call it AB, then that would go with the opposite of A and the opposite of B. Now our last example we'll do the exact same thing and see what results in this one. So we have x squared plus 2x minus 1. And we'll replace the x with the opposite of x. And simplify. So in the first term, we have a negative being raised to an even power, second power. That's going to turn to a positive. So that turns to x squared. The second grouping, a positive times a negative, will get us a negative 2x, and then a minus 1. So when we compare the result with the original problem, we see the first term's the same sign, the second term is the opposite, and the third is the same. So our conclusion on this one is it is neither even or odd, and therefore no symmetry.